Okay, hi everybody. We are going to do the first half of section 8.3, which is using slopes and intercepts. We're going to make this a real quick and real concise kind of a lesson. So let's jump right into it. Okay? First of all, a very quick do now. Pause the video, answer the question, restart the video, and watch my answer to see if you got the same thing. Question is, find the coordinate where the graph meets the x-axis and the coordinate where it meets the y-axis. Okay? So what we've got to do is find, well, first of all, we need to label our axes. We've got an x here, we've got y here, and so the point where it meets the y-axis is right here. That is the point 0, where it meets the y-axis is the point 0, comma 3. Notice this 0 right here? That's going to be important for this lesson here. So just keep that in mind. We then look for the part where it meets the x-axis. The part where it meets the x-axis is right here at -4. -4, comma 0. And what do you know? We have a 0 here as well. But now it's on the y-axis, or the y-coordinate, and before we had the 0 in the x position. Now we have the 0 in the y position. These are both going to be important. Just file those away for later, and we're going to move on. Okay? We've got two definitions to go over. X-intercept is the value of the x where a graph crosses the x-axis. Okay? And that is the point where the y value is 0. So let's look at this graph down here. We have 2 points that are drawn for us. In fact, it's the same graph as from the do now, isn't it? Okay? So we are going to talk about our x-intercept. Our x-intercept is where we touch the x-axis. Here's the x-axis again. So it's where the graph intersects with the x-axis. Okay? And notice, for this point, which we found in the do now was -4, comma 0, our y-coordinate is always, always, always going to be 0. Okay? And the reason for that is that we are actually at position y is 0 because we haven't gone up from the x-axis any. So no matter how far left or right we go, our up or down movement is still 0. So we don't actually think about this 0 as our x-intercept. The only part of the coordinate that matters is this -4. So what we say is our x-intercept for this graph is -4. Every graph will have its own x-intercept. Okay? And the y-intercept is exactly the same. It's the point where our graph touches the y-axis. Remember, this point here is 0, comma 3. And the x-coordinate will always be 0. X value is always 0, whereas the y value is always 0 for the x-intercept. But for the y-intercept, x is always 0, and so the only number we care about is this part right here, the y-coordinate. So the y-intercept, we will say for this graph, is 3. Okay? So let's review that real quick. The x-intercept is the value of x where y is 0. Okay? So for this case, we had -4 there. But it is the value of x where y is 0. Okay? And for y-intercept, it's the point on our graph where x is 0. And it's the value of y where x is 0. So we had 3. Okay? So all it is we're looking for the point where they meet, where the graph meets the x-axis and the y-axis, and those are going to be our intercepts. Okay? This comes in handy when we're thinking about graphing. Okay? Because remember, we only need 2 points to graph, and if we have an x-intercept and a y-intercept, well, there are 2 points, and we can just graph right from there. Okay? So question 1 here tells us to find, or sorry, question A tells us to find the x-intercept and the y-intercept of the equation. 3x plus 4y equals 12. Okay? Well, that's pretty straightforward because remember, for your x-intercept, let me put this in red so that it really highlights it. For your x-intercept, you know that y is going to be 0 because it's hitting the x-axis, and the x-axis is the point where y is always 0. So if I know that my y is 0, then to find my x value where y is 0, look what I do. I take my equation, 3x plus 4y equals 12, and I am just going to plug in, instead of y, I'm going to plug in 0 because I know I'm looking for the point where y is 0. Everything else will stay the same. 3x plus 4 times 0 equals 12. Well, 4 times 0, all of that is just 0, so I can ignore that part. And let's look at what I have now. 3x equals 12. And then to solve this, I will just divide both sides by 3. Divide both sides by 3. And look what I have. X equals 4. And that is my x-intercept. Okay? If I wanted a coordinate for the x-intercept, it's just the point x is 4 and y is 0. So what I would write is 4, 0. But this is not my x-intercept. My x-intercept is just the point that I have circled here in blue, x equals 4. That's my x-intercept. Okay? Or just 4. 4 is my x-intercept. Okay? Now I'm going to do the same thing with y, or for the y-intercept. Okay? And what I need to point out again is that when I'm looking for the y-intercept, remember, in red, so it stands out, this is the point where x equals 0. And now I'm just going to solve like I did before. 3x plus 4y equals 12. Well, instead of x, I'm going to put in our friend 0. And everything else will stay the same. 3 times 0 plus 4y equals 12. Well, look what happens here. 3 times 0 is just 0, so I can cross this out. And look what I have now. I have 4y equals 12. And then to solve for y, I just divide by 4. Divide by 4, and I get that y equals 12 divided by 4, which is 3. My y-intercept, rather, is 3. Okay? So the y-intercept is 3. And I have found my x and my y-intercepts. Now what I'm going to do is I'm going to graph these 2 points. I'm going to put them in, I'm going to create the points in purple so they stand out. Okay, so this first point over here is 4, 0. That was my x-intercept. And my y-intercept was 0, 3. Or those are the coordinates for the intercepts, rather. Okay, so now what I'm going to do, I'm going to graph these 2 points, 4, 0 and 0, 3. 4, 0, I go over 4 and up none. So that's right there. 0, 3, I go over none and up 3. So that's right there. And then all I'm going to do is I am going to connect this with a straight line. More or less straight. Okay? And what I have just graphed is the equation 3x plus 4y equals 12. And so, as usual, this is a linear equation. So what I'm going to do is I am going to say every point on that line is a solution. However, I skipped a step. And here, I couldn't figure out a way to highlight it any more than this. I have this very important thing right here. We need to be able to recognize linear equations just by looking at them. Did you see when I graphed this? This is right over here. I kind of I had 2 points, and I just assumed that it was going to be a straight line. Well, the way I am able to assume that is because I know what a linear equation looks like just by looking at the equation itself. And here's why. A linear equation has 2 different parts that every one of them is going to follow. It has 1 or 2 variables. This one, x and y, it has 2 variables, so I'm still good there. If I didn't have any variables, this would not be a linear equation. If I had too many variables, it would not be a linear equation. But it has 1 or 2 variables, and the more important part, no exponents on any of the variables. And by that, I mean there's nothing written up here above the x or above the y. If this was 3x squared, or 4y to the third, or something like that, that would not work. But because they do not have written variables, they actually do, or written exponents, they actually do have exponents. They're 1, okay, because they're raised to the first power, but we don't even write those. If they don't have exponents, then I know that this could be linear. So let's look at this question right here. Is 3x plus 4y equals 12 linear? I look, I see that it has 2 variables, so that follows rule 1. And then I look to see if it has any powers. No powers, or no exponents written, anyway. And so I'm good there. And I know this is linear, so at that point, I can take these 2 points that I had found, this point right here, and this point right here, okay? And from there, I can just connect them with a straight line because I know by looking at my equation that this is a linear equation, okay? That is very important for you to learn. So go ahead and rewind that and rewatch that part of the video if you need to, because this is one of only 2 important parts in this video. Figuring out how to recognize a linear equation, and then being able to do this. Graph a linear equation by finding the intercepts, okay? Once again, I'm going to look at this equation right here. I'm going to say, is this a linear equation? Well, here's the things I'm going to look for. I'm going to say, do I have 2 variables, or 1 or 2 variables? Yes, I have 2. Do either of them have exponents? Do I have an exponent here? Right there? Or do I have an exponent? Sorry, that's not doing what it's supposed to be doing. Okay, so do I have an exponent here? No. Do I have an exponent on the other one? It's not letting me move it for some reason. Okay, so that's not working. No exponent here, no exponent here. I have only 2 variables, so I know this is going to be linear, just by looking at it. Okay? Now I can find my x and my y intercepts, and here's the way I'm going to do that. To find the x-intercept, I know that my friend y has to be equal to 0. To find my y-intercept, I know that my friend x is going to have to equal 0. And then I'm going to go from there. I start with my equation again. X minus y equals 4. And instead of my y, I'm going to just separate these. Instead of my y, I know that I'm going to put a 0. Everything else stays the same, so I get x minus 0 equals 4. Well, that's just x equals 4. That was easy. And then over here for y-intercept, I know that x is 0, so I start with my equation again. X minus y equals 4. And x is going to equal 0. So I do 0 minus y equals 4, which is just negative y equals 4. Well, if negative y equals 4, then positive y must be the opposite. So positive y is going to equal negative 4. If you didn't see it like that, then what you could say we are doing is multiplying both sides by negative 1. We're dividing both sides by negative 1. It does the same thing. But nevertheless, I get that y is equal to negative 4. So now I want to graph these two intercepts. So I will need to either think about what it means or just write out the coordinate. For the x-intercept, I know that I have 4, comma, y, it has to be 0, so 4, comma, 0. For my y-intercept, I know that x must be 0, so I get 0, comma, negative 4. And now I'm going to plot both of these points. For 4, comma, 0, that's going to be right over here. I go over 4, up nothing, there's my first point. For 0, comma, negative 4, I go down, or I go over nothing, and then down 4. And there's my other point. And now all I'm going to do is I'm going to graph this. Connect the lines. Which is sometimes a little bit easier said than done. But I connect the lines. And I have graphed the linear equation. What was this? X minus y equals 4. So I can label it x minus y equals 4 because I know that that is what I just graphed. See how easy that is? What it does is it takes us from having to write down 5 points and connect them all to only needing to write down 2 and then connect those. And this is very easy because the beauty of this is that you know for an x-intercept that y will be equal to 0. You know for a y-intercept that x will be equal to 0. And that's the power of this because look how easy the math becomes when you make one or the other 0. You can multiply by 0, stuff falls out, and it becomes very, very easy to find your points. Okay? And that's it. What you are going to do right now is you are going to try to find the intercepts to the graph 3x plus 5y equals 15. Remember, you do that by setting first x equal to 0 and then y equal to 0. You find your 2 points, and assuming that you agree this is a linear equation, then you can just graph from there. That's the end of the video. Good luck.